Let's use this angle version of the law of cosines to solve a triangle, or at least find a fourth piece of the triangle. Now, when we had the law of cosines and we applied it to the SAS case, there was only one side that we had available. If we're given gamma, then we had to use the law of cosines to find side C. If we're given angle beta, then we'll use the law of cosines to find side B. We have to find the side opposite the given angle. It's different with the law of cosines angle version. When we have all three sides, we can use the law of cosines to find any angle that we want. So good news, we have a choice of what angle we go after first. Bad news, we have a choice of what angle we go after first. Everybody wants choices until we have to make choices. Like if there were only 3 cars that you could buy, a regular cab truck with a long bed, a minivan, or a sports car. Those are the only 3 cars in existence. It would be easy to be happy with the choice. So I go, well, I have a family that we need to drive around, minivan. I have to haul around lumber, truck. I am just one person, sports car, simple. But now if you're like, oh, I need to buy a compact SUV, it's like there's like so many choices. Too many choices. And you just got to pick one. Fortunately, it's pretty simple here. We just pick one and find it. So let's suppose that we want to find gamma first. We're going to do a cosine inverse of, in this case, the negative one, since we're finding gamma, the negative one is going to be a C, the C. So it's going to be A and B. Those are going to get positive. So I'm going to have A squared plus B squared minus C squared. This is the angle version. And then this gets divided by 2A and B. Now notice I'm writing this super side to side because I want to write down what I'm going to type into my calculator. So I just wrote it side to side. Now in this case, I'm going to need parentheses around the numerator and the denominator. So I'm going to need some parentheses around the numerator. And because the denominator has operations in it, I'm going to need parentheses around the numerator and the denominator. So we'll grab our calculator, move it out of the glare, and then just type cosine inverse of parentheses for the numerator, 8.4 squared plus 14.7 squared minus 10.2 squared. Since we're looking for gamma, C is the one that gets the negative in the numerator. Then we'll divide by the denominator. I need parentheses around the denominator, and it's 2 times 8.4 times 14.7. Close the denominator, close the cosine inverse, and then hit enter. When we're looking for gamma, C is the one that gets negative in the numerator. When we're looking for gamma, C is going to be the negative in the numerator. But we had a choice in what we go after first. Maybe we don't want gamma first, we can find beta first. If we're looking for beta, then it's B that's going to be the negative one in the numerator. So it'll be a minus 14.7 squared. And 8.4 will be positive, and the 10.2 will be positive. And the denominator will be 2 times the 2 positive ones. Wrong color. Oh no, that was the right one. Oh, well. And we're going to need parentheses around the numerator and parentheses around the denominator. And we just type it like we see it. We'll do a cosine inverse of the numerator 8.4 squared plus 10.2 squared minus 14.7 because we're looking for beta, so b is the negative one. Divide by parentheses 2 times the 2 positive ones, 8.4 times 10.2. Close the denominator, close the cosine inverse, hit enter, 104 degrees. One of the things that we should always do when we're solving a triangle, if we have 2 angles, we should just subtract to find the third angle. As soon as we have 2 angles, just subtract to find the third angle. So alpha should just be 180 minus those other 2 angles. When we're playing the solving triangles game, as soon as you know 2 angles, subtract to find the third. But we know that we can use the law of cosines to find any of the angles that we want. And if we're going to use the law of cosines to find alpha, then A is going to be the negative in the numerator, the negative squared in the numerator. And the other 2 will be the positive squares. And as usual, we need parentheses around the numerator because there are operations in the numerator. And we need parentheses around the denominator because there are operations in the denominator. There's our 33.7 degrees. 38.7 degrees. 33.7. This one was also 33.7. I just didn't see it. That's just me needing glasses. That wasn't a bigger version of things. Ah, yes, 33.7. Having a computer, a document camera, and a projector is a very, very excessive way to get magnification, but there it is. That's 33.7. Any questions? Comment? Deep thought? Snide remarks? Fantastic ideas for engine swaps. Every time I see a hatchback, I want to put like a V12 in the back of it, driving the rear wheel. I actually have a hatchback, and I want to put a V12 in the back of it. Oh yeah, the Renault Clio V6s. It's like a crazy turbo V6 too. So it's like excessive. I like excessive cars with excessive amounts of power. I like cars when you see them, people that like the rational person will see that car and say, "What the hell is wrong with you?" Like, oh, let's take a nice practical hatchback and take the practical part and put the engine there. I wonder if they converted the front engine compartment to like the trunk. Trunk. Put a trunk in it. Out of curiosity, apparently there is a company that is converting Chrysler Pacificas to run Hellcats with rear wheel drive. So, because of course they would. I mean, as soon as like a big engine was going to be sold in a crate, it was going to be put into every car in existence, which is a great idea. More importantly, are there any questions on the law of cosine? So the law of cosines is what you start with if you have what I refer to as like one of each type of information, A, B, and C, or A, B, gamma, or A, beta, C, or alpha, B, and C. So you have like an A, a B, and a C. If you have the side angle side case, you really only have one choice. Find the side opposite a given angle. If you have the side case, you can find any of the angles. As usual, as soon as you have two angles, just subtract to find the third angle. Unless you just like to use the law of cosines because it's so cool. It's like, well, hey, Pythagorean theorem, you're so boring. Why don't we use the law of cosines? It's like a super Pythagorean theorem. Pythagorean theorem plus. All right. So tomorrow, no, not tomorrow. Tomorrow we don't meet, but on Wednesday we're going to talk about the other tool we have for oblique triangles, which is the law of sines and the situations under which we can use that. That's going to do it for today. I will see you all on Wednesday. Everybody have a good couple of days, and thanks for playing.